Good morning, and welcome to today's webinar on the topic of how to achieve perfect workpiece surfaces with SINUMERIK MDynamics. Today's presentation will be given by Matt Goska. Matt is the mechatronics engineer with the machine tool group of Siemens in the United States. He specializes in analyzing problems with machine performance, including servo optimization, specialized calibrations, mechanical evaluation, and part program analysis. After Matt's presentation, there will be a short question and answer session. To ask a question, please use the chat function or the Q&A pane within WebEx. So without further delay, welcome Matt.
Hi, I'd like to say thank you to everyone for attending today's web meeting, and we're going to get started right away. MDynamics is it's like a convenience package when you buy a car. It's that we've taken a variety of options that are standalone, available as a la carte for your machines. We've put them into packages that are more convenient to order and also come at a reduced price. So everything that we're talking about you can order it discreetly or you can bundle it as a package. If nothing else, if you're looking for a new machine or if you're a builder, it's a good list to start off of to say, well, I need these pieces, need these, don't need these. It's a very, very convenient place to start because it's most of the common options. The idea with what we've done with this is that we have different packages. Some of these are based off of three-axis machines, the commodity-style machines, up to five-axis aerospace machines. We have different packages for each. The primary thing that we're talking about in terms of the workpiece surfaces is we have a new function called Advanced Surface. This is a next-generation function that replaces what ComCAD used to do, and we'll spend some time talking about that in a few minutes. The MDynamics packages are designed for a variety of industries, anything from energy to mold and die, three-axis job shop, medical parts, aerospace. We even have applications for them within automotive. These next few slides we're going to see are what's in the different packages. Is that if we have an 828 package, those are three-axis or three-axis plus two-axis where you'd have static tables where you can orient your table, and then the table will be locked while you operate. That's what we refer to as 3+2 applications as opposed to full 5-axis when all the rotaries are moving in tandem with the linears. With the 828, we have Advanced Surface, which is the next generation of ComCAD, included as a standard function. 828 is targeted for the job shop environment, and that's just an appropriate function to have in there. There's three chunks of MDynamics that we like to talk about. First chunk is machine performance. There's certain options that help the machine run better. As we have highlighted here, there's a few of them that come in that are related to that. Advanced Surface being new version of the compressor. Spline interpolation, if that's something that you use, so that you can directly program in higher order splines, ABC spline, or NURBS directly. We also have a package that we use for measuring the kinematics of 5-axis machines. It's available where you can put a ball in your work envelope, probe it from a few different orientations, and it will calculate the kinematic offsets of your head. So when we get into the 5-axis flavor of MDynamics, that's included as standard. It doesn't make sense to have that included on a 3-axis package. So if we talk about another phase of how do you make your machines more efficient is production planning. A couple options here that come in that are very, very frequently available to be used. When we say program storage on the internal CF card, as some of you may know, when we switch to 840D solution line, we now have the option of running your user interface directly off the NC hardware, and there's no PC required anymore. This option of program storage on the internal CF card is so that if you are running off the internal version of the UI, it effectively gives you large storage like you would have for a hard drive. I believe this can be expanded up to a maximum of about 4 gigabytes. The transmit and peripheral surface transformations, these are frequently used in the job shop environment, sometimes on lathes, sometimes on mills. What these are is that instead of being like a full 5-axis transformation like Priori, They're a limited transformation that's designed for working on, if you had a lathe and you have a couple pieces of live tooling and you need to make features either on the peripheral or on the face of your part. These are transformations which allow that. We have some slides later on where we'll talk about the details. In the 5-axis package, we have the machining package 5-axis that we've had for years. That's also part of this bundle, which includes Traore. And we also have part of the 5-axis bundle being 3-dimensional tool radius compensation. With 3-dimensional tool radius compensation, this is what allows us to do some of the more exotic offsets in terms of keeping track of the depth that we're inserting a tool into a part so that we can avoid gouges on the floor of the part. The third piece of MDynamics we're going to talk about is operator efficiency. These are things that make life easy for the operator. By making life easier for the operator spends more time running his machine than doing setups. Some of these are going to include things like the shop mill and shop turn work step programming. These are programming packages that you can use at the machine so that if you're doing job shop work and you're doing low volume production and you just want the operator to be able to take a blueprint of a prismatic part, walk up, program it, you can do that. The reason that this is useful when you get into a full-fledged 5-axis machine is that if you occasionally need to make a few one-off parts, either replace a piece of fixturing or some kind of special tooling, it allows you to quickly make that with just using your operator. You don't need to go through an entire part program and involve your programming department. So while yes, everybody who makes CAM systems is going to make part programs that will run more efficiently, the time saving here is that you didn't need the CAM system in the first place. We also have measuring cycles as part of this bundle. Measuring cycles would be our probing cycles in terms of locating your part. And we've developed quite a few new screens to not only define things that would be normal features like the edge of a part or just a round boss or a square boss, but we've got features where we can find partial circles and other things of that nature. We'll get to those later on since we're pretty much finishing up the introduction here. The other new feature that we have is that we also have functions to do 3-dimensional simulation and recording so that the operator can take a part program that he's been handed, run a quick simulation on it, and make sure that what he's going to get is what he thinks he's going to get. In terms of machine performance, we're going to talk mostly about the advanced surface function. Advanced surface is the next generation of COMCAD. It's actually gone through a few iterations since we've seen CAD's new solution line come out. And with that, it's also still being iterated and improved. The intent is that you can program short block part programs, so you can use spacings of maybe 5 micron between points to define a complex surface, including 5-axis programs with your orientation, and have the machine take those points and turn them into a nice smooth curve to represent your part. The idea is that with the new functions, it's faster, we have better part finish, and we can even get higher accuracy. We've also simplified the use of it. When we talk about our compression technology, what we talk about is, if we look on the right here, a normal part program is that even though we do offer technology and program syntax to directly interpret high-order splines, in the field we very, very rarely see that used for a variety of reasons. We accept the fact that most of the programs that are going to be run on our machines that are a complex part are going to be just a series of short points put together. What our compressor functions do is they take these short points, figure out what's the surface that they represent, and we'll string them together as the program is running. The nice thing about this is that if you have very, very, very high density points, faster than what the control could handle in a single clock cycle, it'll compress as many of these as it can into one block internally, and it allows for very, very, very high rates of block execution. For those of you that remember the old Cycle 832 call, we have greatly simplified it, where now it's just Cycle 832, your tolerance value, a 1, 2, or 3 value for roughing, semi-finishing, and finishing, and a 1 meaning new call. A couple slides on, we'll talk about how this affects legacy part programs, especially for those of you with FAA certs on your programs. So with Advanced Surface, what we've done is these are some standard test parts that we use internally to test our own programs. And what we do is these programs, areas that are red represent high path velocity, areas that are blue represent slower areas. And we basically just do a short coloring move over the top of this chess piece. So we bounce back and forth up over the top of it, similar to what you'd do with a mold and die part. Obviously, there's going to be slowdowns as you reverse direction at the end of each pass. But with the newest generations of Advanced Surface, we can see that not only do we have more of the part that's red, which means faster, meaning that we're taking less time to produce the part, we're also seeing fewer and fewer striations. If we look at the far left picture here, we can see striations where we start seeing some of the greens, some of the yellows come through. If we leave those in, those end up showing up as marks on your part. Obviously, we want everything to be smooth. The nice thing is that the setup for this is handled to an end user, is all handled internally. It's a very, very quick and easy call to make. We've also done things so that as you're making pass over, pass over, pass over, pass over the same part, we've also done things to make sure that each adjoining pass is more consistent relative to the previous one. So if you're doing a typical mold and die part where you may be using a 10 micron step over, half thou step over, or even smaller, the new algorithms that we've implemented automatically take care of looking at those and making sure that from one pass to the next pass to the next pass, we're outputting a consistent surface. The reason we show it this way with these drawings we have is that as we move to the right-hand side with the newest generations of Advanced Surface, not only is it being executed more quickly, we're also more consistent. We don't have the yellows and the greens mixed in with the red because these things will show up in a part. This is another sample part that we also use internally. That with the new Advanced Surface functions, we've taken some of the marks out of the part as we transition from a flat surface down through a corner. Again, the easy thing for you is that with Advanced Surface, there's nothing that you need to configure to make this work. You just need to make the Cycle 832 call. Advanced Surface compared to the old flavors of COMCAD, one of the limitations of the older COMCAD was that we were unable to compress the G2 and G3 blocks in with the rest of the program. Now with Advanced Surface, you can have G2 and G3 blocks mixed in the middle. They'll be compressed in, and it'll just run very quickly on the fly. You won't notice difference. We're also now able to compress G0 blocks. So while if you're thinking about a job shop type program, that doesn't sound like a big advantage. If you're thinking about a 2.5D mold and die part, when you're doing a G0 block, you're retracting, you're getting out of the part, you're going to do a tool change or get over into another hole, you're not doing a lot of moving around. Where this comes in is this really comes in for 5-axis programming, where you're going to have to pull out and reorient your head as you're moving to your next feature. What this allows you to do is that it allows you to pull out, stay reasonably close to your part without having to do a very deep retract move, stay close to the part, reorient with a handful of short blocks as you're moving to the next feature. So this does have some substantial time savings when you get into large 5-axis machines that have long pivot lengths. We also have a new function for 5-axis that is becoming very usable. We call it orientation smoothing. This is a 5-axis function only, and the purpose of orientation smoothing is so that, like we have the compressor to deal with when we have the short block programs and there's a few points that are bouncing around and not quite a nice smooth surface, we can compress those just as an XYZ curve. Make them a very, very, very smooth curve. Handle it internally as a high-order curve. What orientation smoothing does is it's effectively the same thing, but it's for a point somewhere up the tool shaft. Because, for example, let's say we look at the program on the left where the nominal line that we drew should be a nice straight line. But the orientation that we've programmed, possibly we're missing a few too many decimals, or possibly we have some bad output out of the CAM system that's not giving us a smooth curve. The problem is this caused a little bit of a deviation on the part program, on the part surface, as we're moving from one point to the next to deal with each deviation from point to point. Now, obviously this causes a bad part surface finish. The other thing that we have to keep in mind is that this is a 5-axis function. When you're dealing with a 5-axis machine, even though this may be a very, very, very small deviation, especially if you're doing something like a composite trimming, where you have a part that may only be 50 thou thick or so, you're going to say, well, I'm that short, the orientation smoothness really isn't going to show up in my part anyway. Well, if you're doing a composite trimming machine, very true. But what will end up happening is that if you're swinging an 18-inch pivot length or so, by the time you multiply that out to 18-inch, you're asking your linear axes carrying that rotary to be moving around quite a bit and maybe making short, quick reversing moves, which is a very high dynamic load on those axes. By smoothing out the orientation, you also get a much faster program execution because we're no longer putting in those short reversal moves on your linear axes. This really comes into effect when you get larger machines. And like I was saying, even if you are dealing with something like composite trimming where it's thin part and you do have more tolerance with respect to surface finish than aluminum structural parts where you've got a cutter buried in 4 inches and you're using the shank of it, it'll still end up giving you faster execution. We can also see some of the other effects of orientation smoothing. This is a top pair of drawings we have here. The colors represent path velocity at the tooltip, where we've gone ahead and basically just thrown in 2 bad orientations as a demo. What this does, what this drawing is showing us, is that with the orientation smoothing function, we're able to, because we don't have those quick reversals that are required putting a high dynamic load on the machine, we're able to maintain path velocity at a higher rate, which means we're going to cut the part faster. We can also see down at the bottom is that the green lines represent the 2 rotary axes and what kind of path we're asking them to follow. It's effectively a pair of points that are somewhere up the tool shaft. But what we're doing is we're taking a pair of sharp corners out of there. And because these sharp corners are gone, we're not going to see it in the wall of the part, and we can run faster. And conveniently, this is a very easy function to activate. The Orison statement that we keep seeing, ORI S for smoothing, on for on, and the ORI SO for smoothing off functions are all we need to use to activate this. There's a tolerance for this as well, but that tolerance is typically set in cycle 832 for you. And these can even be incorporated in with your cycle 832 call, depending on the application. In terms of more convenient programming syntax, cycle 832 with the tolerance and then the 6 decimal coded digits. This is what we've used in the past for activating the compressor as a convenient way. Except we have to make a lot of decisions in here of do we want tray ori on, tray ori off, G64, 641, 642, feed forward on, feed forward off. These are a lot of decisions that don't need to be made on a frequent basis through a part program. With the new cycle 832 call, you'll see that the screen has basically gone blank because most of it's no longer part of the call. All we do now is we give it the tolerance, 1 bit for 1 decimal for saying do we want finishing, roughing, or semi-finishing settings, and then 1 to say that we're using the new settings. This makes it easier to program because now when you're generating your post-processor, you don't have to think about adding in additional tray-ori calls to put in around as a wrapper of your cycle 832 call. Other things, I'm going to move back 1 slide just to talk about a few other things that we don't have to set just to make life easy. For example, feed forward on and feed forward off. There are very, very, very few machines where that's a decision that's made in the part program. Either the machine is configured for feed forward based on its servo optimization, or it's not. You would only typically use one of them. Typically, the way most people set up machines, those are hard-coded, and the commands are ignored anyway. So instead of having to make you guys, as the end user, remember to keep putting in these things that we're going to ignore, the new simplified call is good. Now, the next question that I'm expecting to hear, if we're open for questions, one of the questions I'd be expecting at the end is, so what do I do if I have my stash of 10 years worth of part programs that I've been running on an existing machine, and I want to bring these over to a new one? The existing Cycle 832 calls will still work, and they'll still take advantage of the advanced surface functions. It's just that we're giving you a new way to do it with less effort. So any programs that you have that are using an existing Cycle 832 call do not need to be modified. All right, so that's the end of the portion on the advanced surface part of MDynamics. Now we're going to move on to the section 4. One other thing that I should point out is that based on the list of people who are in this webinar, I know there are a handful of you out there who do have FAA certs on some of your parts, and I know that it is complex to renew those certs if you make any kind of changes. There are options available to revert to legacy versions of the compressor if you have to, but that would be something we're not going to spend much time talking about within the scope of this webinar. The next portion we're going to move on to is MDynamics, and we're going to talk about the production planning portion of this. The idea of this is that with some of the MDynamics functions, we take some of the production planning steps and make it so that you have to do less planning and things just work better. One of the things that's not part of MDynamics but that I really like putting in is that with the new user interface that we call Operate, we are now allowed to load PDFs with your part programs. For those of you who have used workpiece directories in the past to keep either a series of large programs together or to keep some kind of setup information together with your part program, that's a really excellent way now of keeping things together. So you can send down your part program, you can send down a PDF with your setup sheets, you can also send in JPEGs and PNG files as needed, and these are available for the operator to view these at the machine. There are many people who are going through efforts to get to a paperless shop. These can also help if that's one of the efforts that your facility is going for. Talk about Priori again, just because it's a function that we do particularly well. Now, one of the things that we have to keep in mind is that when we're doing Priori programming, if we look at the bottom of this drawing, we've got the same move. It's just a straight linear X move, and we'd have a single rotary axis on there. What Priori does is that it knows about all the kinematic offsets within the head of the machine, so that as you're doing a linear move and you're rotating your rotary axis, it'll move the part that carries the head to compensate for all the motions of your tool. So it's not just if we were to compare this against G93 programming, the left side is effectively what a G93 move would be if we programmed this as a single block, where we'd give it a starting position, an end position, and all the axes would get to the correct tooltip position at the end, but it would leave us a gouge in the part. The way that we've all been getting around that G93 limitation for the last few decades is that we program very, very short blocks. With Priori, since there is no gouging, that means that you're allowed to program longer blocks. The advantages of that is that it puts less load on the compressor, because the compressor is doing the best that it can to interpret the short block programs you've given it. But if you can give it some long blocks, well, program what you actually want. If you have a structural aerospace part and you have have some long blocks in it, give it the long blocks. If you have parts that have complex curves, feed it short blocks. Either way, with the internal handling of the kinematics by the Priori functions, you're going to end up with the smooth surface on the right. The tracefill function is one that we briefly mentioned before. This is not much for the high-end aerospace 5-axis market, but this would be more targeted towards the job shop market. This works on mills that would have a rotary table, or it works on lathes that would have live tooling. The idea is that tracefill stands for transformation cylinder, so that we have a round part, and we want to program in like that, something like that U on the side, where we want to program this as if it was the surface of the part was rolled out as a flat sheet. The nice thing about this is that once you start getting more than one machine, everything I'm about to say also applies to trailery as well. When you start getting more than one machine, or you have to recover from a crash, because all the kinematic information is stored internally to the control, yes, you'll have to recalibrate. You don't have to adjust any of your part programs after a crash, or if you want to take programs and migrate them from one machine to a sibling machine, because each machine stores its own kinematic data, the same program will run, you'll get the same quality part out without having to make any program-specific adjustments from machine to machine. Now we're going to talk about some of the new functions that we've added in the operator efficiency component of this. One of the things that we've done is that, especially for the end users that have a variety of different machines from different builders, and we'll have 5-axis milling machines, you may have some lathes, you may have who knows what. We've made a very, very, very concentrated effort to keep all the buttons as much in the same place as we change from one technology to another. What we call operate. Operate is the replacement for HMI Advanced, so it's your user interface. What we call operate universal is something that is the base package with nothing else added, and it's something that we would use on complex machines that really don't have a milling or turning technology. For example, if we're doing carbon fiber placement or other specialized machines like that, we'd use just universal. If we have a turning machine, we'd usually recommend the turning option. For a milling machine, we'd usually recommend the milling option. The nice thing is that these buttons here are very, very easy for the operator to use. What they are is that, for example, if we say that measure workpiece button, that brings up a series of other buttons so that the operator can very quickly just load up a probe to the machine, jog it near some feature, quickly locate that feature, and set a work offset. Similarly, measure tool would be if you have a tool probe enabled on your machine. It's a very quick way of saying, measure the tool that I currently have in my spindle. There's also other functions like this TSM function, which are a very quick way of, instead of having to write a decent-sized MDA program, you can just say, run my spindle at 500 RPM and do one quick linear move. One of the examples that we have is the workpiece measurement. So this would be, how do you have your operator locate your part? The idea is that if we look on the left edge of this, these would be the horizontal soft keys that you would normally see. And so it's showing you what you would get from each. So if you want to calibrate your probe, well, do you want to calibrate your probe on a length? Do you want to calibrate the radius in a ring? Do you want to get it from a radius at an edge? Do you want to do it off of the sphere? There's a variety of ways you can do this. The convenient thing is that we also very quickly start breaking these down into pictures, so the operator doesn't have to remember the syntax. He just has to think about, well, what is it going to look like, what I want to do? Do I want to work on the outside of a part, or am I working on the inside of a part? In terms of other operator efficiency things that we've added, we've also redesigned a large part of our tool layout, tool setup pages, where it's now much more graphical. We support turning tools with a variety of orientations as shown in the upper left drawing. We support grinding tools now, and we also support a variety of milling tools. Now, while for a lot of places it's not entirely critical to have to identify the tool types well, there are certain features that can really take advantage of have you defined your tool types correctly. For example, if you're dealing with a part that has a countersink, and you need to say that, well, the diameter of my countersink needs to be 249 thousandths. You say that I'm going to use a drill bit with a 118-degree angle on the tip, and it's this diameter. One of the screens that we're going to talk about later, you can just say that we'll make this counter bore and the control will do the calculation for you. So if you're going to be doing things at the machine where you can take advantage of that, it's worth setting up and punching in the numbers correctly. In a lot of aerospace shops, they tend to skip this step because the data is coming in from somewhere else. You don't want the operator touching these screens. If you don't define the tools correctly, the machine's still functional. But when you start getting into the programming of the machine functions, this does save quite a bit of time for your operator. When we talk about work step programming, what we have is that the idea is that your operator should be able to take a blueprint, walk up to the machine, and very quickly just write a part. So this is a typical example of a work step program where we say, all right, the first thing we're going to do is do a face milling operation just to clean off the top of our part. We can cursor through this program, enter some parameters, say that we have a block that's this big, we have our work offset set at such and such point. Pick this face mill out, run it at such and such a depth with such and such step over. Go ahead. Go ahead and leave some kind of rectangular feature on the top. Then we'll define a bolt pattern, which is about the fourth slide in that cascade, where we've got a rectangular pattern. And then we're going to say we need to center drill it, deep hole, peck drill it, tap it, and do that for each of the circles. Now, again, this wouldn't be the kind of thing that you'd use for your volume production things, but this is for your one-offs. If you need a piece of fixturing to be made, if you have some special prototype orders that come in, this is a very, very quick way for your operator to just get a part out the door without having to get it through your CAM department, get it back out to the machine, and then have a final part made. So it cuts out a lot of the time that you would use just in passing work from one department to another. You're also allowed to make part programs with some decent contours in them. One of the examples we have here on the left is just a rectangular boss that would be coming around from the outside for some kind of widget. The other function, another function we have, we call it residual material detection. If we look on the right, let's say that we wanted to make some pocket that's going to be just a pretty straight thing, and it's going to have a couple small radii on the corners, but it's fairly big, so we want the control to come in, grab a large roughing tool like a half-inch corn cob, a 1-inch corn cob, come in, clean out most of the material from that pocket. Great. Problem is, we've got one large radius on that part, and we've got 3 small radii. The function we call residual material detection, what it does is it says, all right, we know that we just did this roughing operation. We know that we have to go clean up those orange chunks out of each corner. Well, now we're going to use a smaller, more appropriately sized tool, and the only part it's going to cut out is just the leftover residual material, which does save quite a bit of time, which means that when you have your operator who's doing these operations by hand, he doesn't have the full CAM system supporting him. These things are still possible. In terms of other things that they can do is that if you need to do make bores or bosses that have to do press fits, we do have a fit calculator built into the control. So you can give it the nominal diameter and then also give it its fit class by letter grade. The control will calculate these for you. This would be another case when it's important to give the tool data setup all the information about the tool. This is again a job shop and one-off targeted feature. In terms of making things easier for the operator when he's programming at the machine, we've also gone to quite a bit of effort to make a lot of these functions animated and to try to show you that show your operator that as he changes parameters on the screen, the function changes. Even simple things like if he wants to change from quine milling to conventional milling, when he selects that button on the screen, it'll flip the toolpath around for him and show him that it's running the other way. One of the things that we've gotten from the cutting tool vendors is a cycle called tricoil milling. You may be familiar with this because what it does is it effectively does an offset circular path through a part that is quite optimal for the chip load, helping you with remove material faster and keeping you maintaining longer tool life. This can be entered right at the machine by your operator. So even if he's doing just simple, we need this fixture made up for such and such, we need a piece of mounting made for such and such, and he just needs to make a large, clear out a lot of material quickly. Instead of having him say, yeah, I can program this on the machine, but it's going to be with a really inefficient path, we have functions like these torcoidal cycles built in so that you can do this in a very efficient manner. We also have engraving cycles built in. So even if you need to do something like putting a serial number on each one of your parts, or if you need to mill in the word prototype or some other model number that you need, these are available where the operator can do these just standing there at the machine, type them in, no CAM system involved. Back to the measuring cycles we were talking about. Some of the more exotic measuring cycles we have taken a few screenshots and put them off to the right. The idea is that now if we have to locate the center of a circular feature where we have a side locked off, we can do that by locating a handful of points on the circle. We don't need the entire boss or hole to be present. If we look at the upper left corner picture, we can also see that if we're trying to locate inside of a pocket and we have some kind of boss or other collision obstacle in the middle, these manual cycles for the operator, all he has to do is load the probe, drive the machine to more or less over the center, pick up some of these graphical sheets and say, well, I want to probe the center of the circle, and I know I have this obstacle that's roughly here, that's roughly this size, that I need to avoid, and let the control do the math for him. Cycle 800 is something that we've been using for a few years within both 5-axis and 3+2-axis machining. Cycle 800 is a sibling to Traore, but the difference is when we're doing true Traore programming, we're always programming relative to our work coordinates. With Cycle 800, the idea is that we take our work coordinates, we move them to some feature, and then tell the machine to line up the tool so that the Z-axis the tool is pointing up the Z-axis. The typical example I like to use for this, because it's very easy to imagine, is a V8 engine block. So let's say we're making V8 engine blocks and we want to do some operation on both heads. We load the part to our machine. We say that the crankshaft center is 0, 0, 0 for our work coordinates. We go ahead, we locate it however we have to locate it. Then we would use Cycle 800 to move our coordinate system up to one head. We'd say that we need to make some shift in X and Y and Z, and we also need to roll it so that the Z-axis is now pointing straight out of the head, up the piston shaft. What this does is it lets the operator, he can very easily say that, okay, well, I know I need to move these distances, I know I need to roll this, and even with complex kinematics like nutating heads, he doesn't need to think about what the kinematics are. All he has to do is say, well, just move everything and line it up for me. That's why we have calculators and computers. This works with nutating heads. It works with nutating tables. It'll work with standard C carries A style tables. It'll work with C carries A and C carries B rotary heads. And the beauty is that once he's moved this coordinate system to his new face, then all the measuring cycles, all the drilling cycles, all the G2, G3 type things are all relative to that new face that he's programmed. In terms of other things that he can do is that when he's programming at the machine and he wants to make sure that, yes, what I told the machine to do is actually going to happen, if you have a reasonable piece of stock that's basically rectangular, basically cylindrical, you can simulate a full program. You can even simulate a full 5-axis program, and it will show you what effects the shaft of the tool is having on the part. If you're working from something that's, this is basically the same slide, but the highlight of this one is showing that we have that somewhat rounded boss on the bottom, and it is able to show us the effects of the tool shaft on the side of the part. Now, if you're dealing with an aerospace part that's more complex, or if you're dealing with a complicated mold and die part where you really don't need to see all those details and you just want to have it done quickly, we have a function called Quick View, which is a 3D modeling simulation that takes the part program points and just prints them out, displays them as a wireframe. Especially for the aerospace guys, where the stock material you're starting with is not a nice, easy rectangular or cylindrical part. It's probably some kind of piece that's been partially roughed already, or it's some kind of composite, complex composite that you're trimming. This will at least let you see that, yes, that looks like the part that I think I'm going to be making, and there are no strange G0 moves right into my table. And this will run, these simulations can run very, very, very quickly on part programs with high density points. So while no, it's not as good as something like the VeriCut analysis that many of you do, it's enough for the operator just to make sure, does the paperwork I have match the software thing that they gave me? Another function that we use that's especially good for job shop work is when you have one part where you may have to take it through 3 fixtures. So you would do the top face in your first vise, you'd roll it over, put it in a second vise, roll it over again, put it in the third vise. So you've got 3 vices set up on your table and you're moving parts through. This multiple clamping function that we have, what it allows you to do is set up the 3 vices like that. And you can say that my first vise has 1 work offset, second vise has a second work offset, third vise is a third work offset. You identify the work offset for each program. You say that I'm running 3 different part programs. What the control can do as the operator is standing there is take those 3 programs, look for the different tool change cycles within them, and say that, all right, so I need a number 10 center drill for these operations on my first part. I need it for these operations on my second part. I need it for these on my third part. And it'll do all the center drill operations without a tool change. Then it'll go through and say, all right, and now I need to put in a drill out for tapping. It'll work on all 3 parts at once. So it'll take these programs, condense them together. And it does this based on when the different tool changes are called. We've also made it quite a bit more intuitive for the operator to use, not in terms of only all these graphical elements, but our operator panels have always had a help key on them. We have made the help key much more context aware, so that as you're in a screen, you press the help key, you'll get quite a bit more details right there of what do all these terms mean? What do these acronyms mean? What are the abbreviations? It's even substantial enough so that if you're staring at a G-code program and you forget, what's G41 and what's G42? Which one's left and which one's right? You can type in G41, press the help key. It'll bring up the context-aware help. And that's the end of the planned part of this presentation. And we're going to open up for questions.
All right. Once again, if you have questions, please use either the chat function or the Q&A pane within WebEx. A couple questions have come in, so while maybe some other people in the audience will send something in, I'll start with question number 1. Can CYCLEBOO MDynamics be enabled by an end user?
Generally speaking, the best way to enable and make sure that it's set up correctly is to contact your builder or your dealer. While it's not a particularly complex function to set up, there are certain things that it would be best if you contact your builder.
Okay. Another question that has come in. How much of this is available for my existing 840D Powerline machines?
The answer is that not that much. Most of these functions are unique to Solution Line. The internal functions behind the compressor, or what we're now calling advanced surface, they're one of the areas where there's been a continuous effort from our development group. For Powerline machines, we offer a series of services that we call productivity improvement, which is available at a fraction of the cost of a full machine retrofit. So if you have a 840D Powerline machine that's more than about 5 years old or so, these productivity improvement services that we offer could include NCU and PCU 50 upgrades, getting you faster hardware, also getting us some of the newer developments in the compressors since when you purchased your machine. So even within the power line generation, there were advancements in the compressor regularly happening. So one of these productivity improvements may be good for you. The other things that the productivity improvements also give you is that we'll take a look at what generations of hardware do you have, and if you have things that are where the parts are becoming less and less available, we may be able to upgrade those to newer parts that will have a longer-term product support lifespan. When we do these, we may also offer machine optimization services, where one of our engineers will come through and re-optimize the machine, make sure that the commands that we're sending to the motors are what they're actually doing, and that we can get the best performance at your tooltip based on some new functions that we may have thanks to one of these software upgrades.
Okay. A third question that has come in. I have an 840 DSL machine with HMI Advanced. What's available for me?
In terms of most of the operator functions, very few of them are going to be available with HMI Advanced. These are unique to operate only. If you have HMI Advanced, the advanced surface functions still can be enabled. It is possible, because as we're discussing quite a few slides back, I'll slide back somewhere near the beginning, is that when we do our Cycle 832 call, even if we use the legacy Cycle 832 call that we've used from HMI Advanced, it's still activating the advanced surface function. Same with the orientation smoothing function. That's not dependent on the user interface.
Okay. Let me check here. Looks like there's one other question. I really like what I see and can find some definite benefits to MDynamics. How do I purchase it?
The best way to purchase this is that if you're an end user, contact either your machine builder or your dealer. If you're a machine builder or dealer, you would contact your regular Siemens representative, and we can help you get these set up. They're not particularly difficult to set up, but there are a few things that you do need to be aware of to do it correctly and make sure that you are getting all the benefits of it.
Okay. Let me check one more time. Looks like that there's nothing else in the chat, and there's nothing in Q&A. So with that, we thank you for your time, for taking the time to learn about SINUMERIK MDynamics and achieving perfect workpiece surfaces. Please check out our next webinar series. You can find all that information on the web, usa.siemens.com/CNC4U. That's the number 4, Y-O-U. And click on the Webinars tab in the left-hand navigation. Again, thanks very much for your time, and we appreciate it. Have a great day.